Okay, so this is actually the second part of lesson 3 that we're talking about today. And when I tried to record the first part of lesson 3, we had some technical difficulties. So if you haven't seen the first part of lesson 3, this isn't going to make any sense unless you've read up on it. So what I'm basically doing today, if you look at the actual lessons, is I am starting at section 3.2 of the lessons. So just make sure that you've read through section 3.1 and you understand it pretty thoroughly before you dive in here, or it's not going to make any sense. Okay, so I had a question about one of the style conventions says that you should never say something like if something return true, else return false. Or I don't have this in there, but a similar way of saying this would be if something return true, and then just return false. Same thing. Those are equivalent, right? Okay. But there's a much better way of saying both of those. So there's a third thing here that's equivalent to both of those, and that's return something, right? Does that make sense to everybody? Because what this is saying here is if something is true, return true, else return false. Isn't that just another way of saying whatever something is, just return it, right? I'll let you think about that, if it doesn't make sense. Okay.
As long as the function has a return of a Boolean and not an object, where actually if you return something, would you return it?
Well, this presumably that is a logical expression. So let me think about that for a sec. I suppose in C++ actually you could put something there that's not a logical expression, and C++ will allow it, and it'll figure out some way of deciding whether it thinks it's true or false. Okay, but that's not really what we want to do anyway. So I guess what I'm doing here is limiting this to the situation where we're actually putting a logical expression there. Okay. Yep. Let me talk about that later. I have to think about that. Okay. Whoops. What did I just do? Oh, I don't want that. I want pink, and I want. Did I just kill? Whoa. Okay. What the heck? I hit the X and that quits out of it. That's my Mac. Oh, yay, that was easy. Okay. All right. So going back to what we had last time, we had completed this code that you see right here over on the left, and this picture over on the right here is what that code creates. Okay. So if that doesn't make sense, you probably need to go back and review what we've done so far a little more. Any questions about that before I dive into what's next? Okay. So the next thing I want to do is I want to add some statements to my client program that just kind of test out the assignment operator. Okay? So By the way, I'll just say that I think that we're not going to be able to see both of those at the same time. I think that what we're doing today may just be, it's close to the most important lecture that you're going to get in this semester. So this is one of those where you really want to be awake for it. Okay. So maybe it's a good thing that the recording's actually working. Okay, so take a look at this and tell me if it makes sense. We're just saying setting item 1 equal to item 2, and then I'm printing it out, some statements to make sure that it actually did what we expected, right? So this should print out after item 1 gets item 2, item 1 is, what was item 2? Item 2 was 9 hammer, right? Actually, we can see from the picture, item 2 is 9 hammer. So item 1 is 9 hammer, item 2 is 9 hammer, right? Okay, and then we're going to set item 2 to lawnmower 14, and so then after item 2 got set into lawnmower 14, item 1 is still 9 hammer, item 2 is lawnmower 14 lawnmower, right? So, and I actually, now that I've read all that to you, I actually have it down here somewhere, I think. That's the expected output right there, right? Okay, so let's go ahead and run this. Okay, so there's our output. Let me compare it to our expected output. Is that what we wanted? What's different?
Oh, item 1 on the very bottom is 9 lawnmowers instead of 9 hammer.
Right. So at the bottom here, we were expecting item 1 to be 9 hammer, but it says 9 lawnmower. Any guesses about? Whoa, my computer's flashing at me. Any guesses about what might have gone on there? Sorry?
Because of the pointer is pointing at
Yes, basically. But even to just maybe at a higher level take a look at it, it kind of seems like maybe when we said item 1 is equal, well, when we said item 2 dot set info, apparently that didn't just set the info in item 2, it set the info in item 1 as well, right? That's what it looks like anyway. So let's go ahead. What I want to do is draw our picture. Okay, drawing pictures is a very important part of this class. You'll see. So we're right here. Item 1 gets item 2. Basically, what's going to happen when we say item 1 gets item 2 is, well, first of all, let me just point out that it's interesting that we can do that in C++, right? It doesn't give us a syntax error, which means that C++ allows us to do the assignment operator on objects, right? Okay. However, what it does is whenever we do an assignment operator on objects, it just copies each member one at a time. So it's called a member-wise assignment. So when I say item 1 gets item 2, that means item 1.units is getting item 2.units. So this becomes 9. Okay? And then item 1.description gets item 2.description, which means that's a pointer assignment, right? So we talked about how basically that means make item 1.description point at whatever item 2.description is pointing at, right? So that's our picture now, right? So There's a couple bad things about this, right? The first bad thing is that we have a memory leak. Right? Remember we talked about memory leaks last time? We have some data over here on the heap now, and we have no way of accessing that. So as long as our program is running, that piece of memory out there on the heap is unavailable. Right? Probably not that big of a deal, but if this was in a loop or something like that, and we were allocating a lot of memory like this, we could run out, or we could get low on memory. But more importantly, what we're seeing here now is that when I say item2.setInfo, lawnmower 14, what that means is actually I need to erase all of this, huh? Believe it or not, I think this is probably going to be faster than.
Let me give you a bigger eraser.
What did I just do? I think I hit the right mouse button, so there must be something. I can make my eraser bigger. Maybe that's the best way to do it. Hold on. You think? No. Oh well. Bear with me. It'll just take 10 seconds, as long as I don't hit the right mouse button again. Okay. So set info, item2.setInfo, 14 goes there, and out here is going to be lawnmower, right? So I'm not going to be able to fit that, huh? We'll just, yeah, dot. One. Okay, so L A W W and then dot, and this is going to be ER\0. ER\0. And we this is pointing to it. Okay. And this is also still pointing at it. Okay? So that's why right here in our output it says 9. That's what we wanted, sorry. In our output it said, what did it say, 9 lawnmower, right? Because the 9 is still here in item 1, but if I follow the arrow, now item 1.description is lawnmower. Oh, yes?
Are you going to explain why item 1 points to lawnmower rather than hammer?
Why what?
Are you going to explain in detail why item 1 points to lawnmower rather than hammer? Because that doesn't make sense.
Rather than hammer?
Yeah.
Well, so I'm glad you asked that because I wasn't going to explain anymore. The deal is that item 1.description was pointing down here to the same thing that item 2 was pointing at. So if I change this over here, and you look at the picture, item 1.description is also changing.
But you're not really changing what's over there, right? You're deleting that and
right.
So why does the second pointer also get it?
So okay, so that's a good question. And so I know the answer to that. I'm just trying to decide how to explain it without losing everybody. So as far as basically what's going on there is that I'm saying delete. Okay, so I'm giving you the actual technical answer here, okay, which I hope isn't too confusing. I'm actually using delete, and this is going away, and then I'm saying new, and I'm allocating more memory, and coincidentally, it's being allocated in exactly the same spot it was where I deleted it from. Okay, and then and item 1.description is still pointing to that same piece of memory. And so when I say item 2.description gets lawnmower, I'm also changing item 1.description. Yes, that's what's happening. Okay, but that's hold on just a second. That's actually, you know. So I'll be honest here for a second, right? The first 3 times that I taught this class, I didn't actually realize that as I was explaining it, and no one ever asked me about it. And then one day I went, oh yeah, that is what's happening, huh? So normally, you know, typically in an example like this, I would be doing something like, okay, let's just change let's change hammer to something else without deallocating and allocating again. If that happened, then that would be a perfect example, right? A simple example of why changing item 2.description also changes item 1.description. So if you completely if I lost you totally in the last 3 minutes, it's probably okay to just think of it as, okay, this right here changed because I was changing item 2, and because item 1 is pointing at the same thing, it also changed item 1. Okay. Do you want me to say that again? That's like that's the bottom line that you need to understand. Question? Sorry, I know you have to. Oh yeah.
You said that memory locations coincidentally the same.
Yeah.
Is that just because they're both items the same thing?
Okay, so no.
Is that just the nature of how
Yeah, I
the
mean.
program would handle the situation?
Yeah. So there's no guarantee in C++ that if I say delete and then I immediately say new, I'm going to get that same piece of memory back again. But as many times as I've ever run this, that's always what happens. So I get the same piece of memory back again. So really, it really is just like I'm changing this from hammer to lawnmower. Okay. Do you still have a question?
So if you were to coincidentally allocate lawnmower in a different location, would item 1 return gibberish?
Yes. Yeah, that's an interesting question. I mean, we're going pretty deep here. So here I'm trying to figure out how to make this work if you're not following this discussion, because it's a pretty subtle point we're talking about here. Basically, what you need to know is that using the default assignment operator that does member-wise assignment isn't going to get you a completely separate copy of item 1. Does that make sense? What we really want right here, when we say item 1 gets item 2, we want item 1 to be a completely separate copy of item 2. We don't want it to be, the same memory location or anything like that as item 2. But that's not what happens. Everyone okay with that? Okay. So what are we going to do about that? We can't use the assignment operator? Well, actually, if we were using Java, that would be true. We would not be able to use the assignment operator. We'd have to figure out some other way to do it. We'd write a function called copy item, and we'd copy it that way. We wouldn't use the assignment operator, okay? But in C++, we can overload operators. So let's overload the assignment operator and make it do what we want it to do. That makes sense? Which is nice, because then when our client programmer declares an object of type inventory item, they can just use the assignment operator the way they're used to using it on other types, and they don't have to worry about it. Okay? Same with strings, right? When we declare an object of type string, we get to use the assignment operator with strings. You probably didn't even think about it. Okay? All right. So We're going to overload the assignment operator. So, what value does the assignment operator return? Is it void? Okay. Void. Okay, let me just go to the bottom here and use this as kind of white space here. So if I say A gets B, hold on, let me see. A okay, keep changing my mind. A gets B gets C in C++, or even say 7. Okay, does that work? Is that going to assign 7 to both A and B? The answer is yes, that'll work. Okay. So what that means is, look, right here we're using the assignment operator, and it's not returning void, right? It must be returning something because it's being used right in there as an expression, right? So what do you suppose it returns? You know, I want this to go the other way, actually. Hold on. No, not that other way. A gets B gets 7. Okay, that's what I want. So when so the assignment operator is right associative. So that means that I'm doing this assignment operator first before I'm doing the left one. Okay? So I do B gets 7. That's fine, no problem, right? What is going to get placed here so that the A gets whatever works? Say that again?
The B.
The B, yeah, pretty much, but, sorry. So what's actually going to happen is this is going to say A gets 7, right? So what the assignment operator returns is whatever the value was that got assigned. That make sense? If you want to come in and find a desk, it won't offend me. I don't mind the little disruptions. Big disruptions, yeah. But, okay, does that make sense? The assignment operator returns whatever the value was that got assigned. So in this case, what's the return type going to be? Inv item, right? We're assigning one inv item to another, so the return type is going to be inv item. Operator assignment. Okay. So how many parameters are there going to be? The left operand is going to be the calling object. So the right operand is going to be the parameter. So so the right operand is going to be something of type inv item, and we're not changing the right operand, so it's going to be const. Okay, so there's my prototype. So here we go. Return type, scope. Oops. Okay. So let me just, I always like to start with like sort of, okay, conceptually, here's what we want to say, and type it out, and then look at it and go, okay, You know, what's wrong with that? How can we make it so it actually works technically? Okay, but conceptually, all we want to say here is units gets right dot units and description gets right dot description. Oops. Okay. Does it make sense to everyone why I'm saying that's sort of conceptually what we want to do here? Right? We want to just assign each member to the other one, right? So what's the problem with this? Yeah. Okay. Your pointer is going to be pointing at the same memory space. This is just making the pointer of one point at the other one. What I want to do is make an entire copy and make the pointer point at that, right? So, and another way of putting it is that actually this, what I have here is exactly what C++ does by default, right? The thing we just saw happen, that's exactly what this is doing. So we want to first create a new block of memory for the description to point at, right? So how do we say that? Description gets new so what is it going to be? It's going to be an array of characters, right? So new car, how big is it going to be? Sterling of right dot description plus 1 for the null character. That make sense?
You want the description first.
Good question. Hold on to that for just a second. Let me make sure I've got this right. Okay, the next, then is that what I would want to say next? No. No, okay. In fact, just put this in as a little kind of hint in your brain, okay? If you ever see, you know, something gets new, and then in the next line you see the same something gets something else, you're doing something wrong, right? Because you just created new memory and made description point at it, and then the very next thing you're doing is making description point at something different. Okay? So that's not right. What is it that we actually want to do here? Okay, so what we want is we're looking at this picture here. See, now what I want to do is go back to the original picture. If I hit Control-Z enough times, will I go back? I don't think so. So the original picture was 9 screwdriver and 5 screwdriver and 9 hammer, right? Give me just a minute and see if I can come up with at least an approximation of that. So this was 5, and this was 9, right? And this actually pointed at the screwdriver. Okay, and this pointed at actually hammer, right? So I'm not gonna bother with all of the boxes and everything this time because you have seen that enough. I'm just gonna say HAMMER \0, right? Okay. So what I want to do now is, okay, so I've said description gets new car Sterling right dot description. So what that does is it is going to make this point at a new piece of memory, right? So right away that tells us what? We need to delete first That make sense to everybody? Right? I mean, the next thing I need to do is make description point at something else. And if I do that, this memory here is going to be lost. Okay? So what I need to do here is delete description. Okay? Here's another rule of thumb. Every time you see you have a pointer and you say the pointer gets something, ask yourself if you need to delete what it was pointing at before. Every time you have a pointer assignment. Okay? Especially if it's a pointer to a new something. Okay? Just double check that. Okay, so we've deleted this. It's not quite as fast as a chalkboard, but almost. Okay? And we're saying gets new character, Sterling, write that description plus 1. So we have set aside some space here that's the same size as the hammer array, right? So I can do that quickly, I think. I'm not going to draw the individual boxes. I'm just going to go like this. Okay? That's the space we've set aside. So what we have to do now is we have to make these characters down here go into this box, right? And the way we have to do that is with stir copy. I mean, we could do it manually with a for loop, right? For count gets 0, count less than Sterling write that description, and so on. So stir copy is really just someone already wrote the for loop for us. So stir copy, description, write dot description. Okay. So this is the calling object now, right? Because in my client I said item 1 gets item 2. So item 1 is the calling object. So when I say description, I mean this right here. Okay, and so we're saying, so this stir copy statement says copy the hammer up here. Hammer \0. Okay, the stir copy also does the \0.
Let's get the deprecation warnings with string copy with one maybe use underscore S.
Yeah, so the question is, why does my compiler give me all these warnings whenever I try to use stir copy? I think that you're using Visual Studio, right? Because Microsoft has its own way of thinking about the world, and they have their own special functions that are safer versions of stir copy and stir cat and all of these other stir functions. And they think that you shouldn't use stir copy because it's not as safe. As far as I know, you won't get that error message in other compilers. It's not an error message, it's a warning message. Okay? What is unsafe about stir copy? What's unsafe about it is, go ahead. Did you have a? I think you're on the right track, but basically, there's no, if you use stir copy, it's not going to check and make sure that the thing you're copying into is actually a memory that's been allocated. It's not going to check and make sure that you don't copy too many characters over. So if you allocated an array of 4 and you try to copy the word, California in, stir copy is just going to blindly go try to do it. And sometimes it might actually work, or sometimes it might actually be writing on top of other variables that you've allocated. Okay, so basically stir copy just blindly does everything without checking to make sure that you've got all your ducks in a row. Okay, that's why when you're working on assignment 2 and assignment 3, you're going to have to be very careful to make sure you've got all that handled. Okay? All right, so let's see how we're doing here. Are we done with assignment? We need a return statement. And I'm just going to say return star this. Okay? Because that's going to be the value we got assigned. Return star this makes sense to everybody?
Yeah.
Okay. So now I don't know, this is a digression just for a second here, but I remember when I first introduced you to star this, I said, just ignore the star, and star this is a way that you refer to the calling object, right? Now that you know what the star means, the right way to say that actually is that this is a pointer to the calling object, right? So if I say star this, that gives me the calling object itself. Okay. All right, shall we try this? Let's see if we get the results we were expecting now. So I guess to back in our main function, to continue on with the picture here, now that we've got it set up like this after the, oops, there's one more thing here. This became 9, right? Okay, so we've done our assignment operator, and we've got this picture now, which is what we really want, right? And so now when we say item 2.setInfo lawnmower 14, we're going to get, oops, lawnmower here and 14 here. Okay, and then I'm going to say, see how item 1 is 9 hammer, item 2 is 14 lawnmower. Okay, 9 hammer, 14 lawnmower. So we fixed the assignment operator, right? Okay, let me add some more code because I want to test, and this may seem a little odd to some of you, but I'm going to do it anyway. If I can find it. Oh, down at the bottom here, I pasted some code in. What I want to do is there like really bad music playing next door? What is that?
I hear singing or something.
Okay. I'm glad I wasn't just imagining that. Okay. I'm going to assign item 1 to itself. Okay? So, and then this should say after item 1 gets item 1 is still, maybe I should put the word still in there, 9 hammer, right? Yeah. Okay, let's try it. Someone is taking a nap and is very happy about it, I guess. Okay, so something went wrong, right? Let's take a look. Okay, here's our assignment operator. Okay, so we did units gets right.units. That's fine. That's just 9 gets 9, right? And then the next thing I do is delete description, which means that now description, I'm not going to draw this, I don't think. Description's just pointing at junk now, right? And then I say description gets new car length, Sterling, right.description, but that's the same, as a pointer at the same thing, right? Because the calling object and right are the same object. That makes sense? Okay. So let me say it another way. when I delete the calling object, or in other words, when I deallocate the memory that the calling object is pointing at, I'm also deallocating the memory that the parameter right is pointing at, because they're actually the same object. Okay? So, how can I avoid that? Say that again? Make a copy again. So basically what I want to do here, if the two things are the same object, then I just don't want to do anything. They already equal each other, right? That make sense? So I don't actually want to make another copy if I say item 1 gets item 1, right? Because they're the same object, right? They're the same value. So basically, if the objects are the same, then I don't want to. I just don't want to do anything, right? I'm done. So. Actually, my initial instinct might be to say something like this: if star this is not equal to right, then do all this stuff. Okay, don't write that down yet, but does that make sense why I would say that? So if star this, if the calling object and the parameter right are not equal, then go ahead and do this. Okay. The problem with that is that, well, there's a couple problems. One is I may not even have a not equal to operator defined for objects of type invitem, right? But even if I do, I am not really concerned about whether the objects are equal. What I want to know is whether they are exactly the same object. Okay, that didn't make sense. Let me say it again. If they are two different objects that happen to be equal, then I can go ahead and execute those statements. I want to go ahead and execute those statements, right? The time that I don't want to execute those two statements is when they are actually the same object. And so the way that I'm going to test that is I'm going to see if they have the same address. That make sense? If I have two different objects with two different addresses, I want to go ahead and execute those statements. So what I want to check here is if the address of the calling object is not equal to the address of the parameter. So the address of the calling object is just this by itself. And the address of right, how am I going to do that? Address of. Okay? Yeah. I'm sorry, say that one more time. I'm having trouble hearing you. It's okay.
You put the parameter, but you don't change the value of y.
You mean I put you're talking about this right here?
Yeah, the ampersand.
Oh, the ampersand. No, I'm putting that because I want to know if the address of, I want to know if these are exactly the same object. So I'm checking to see if the address of the calling object is the same as the address of the right parameter. And the ampersand is, I introduced this right at the beginning of the pointers lecture, so you may have forgotten about it, but it's the address of operator. Okay, so it just gives me the address of whatever that thing there is.
Could you use address of on this if you wanted it just for clarity's sake, or would that cause?
No, that would mean the address of the pointer that's pointing at this, right? So, yeah, that wouldn't work.
Make things too
This is a pointer, right? So, which is another way of saying it's an address. Yeah. Okay. So in other words, what I'm doing is this.
Right, that's what I was thinking.
Right? The address of the calling object is if the address of the calling object is not equal to the address of right. Okay? But this is just a more complicated way of saying this. Right? Okay. All right, what do you think? Should we try it? Go ahead.
So this will not only make it that if we say item 1 equals item 1, it'll skip the whole process of
Right.
trying to have them equal. But if item 1 and item 2 are the same thing, will this do the...
So the question is, if item 1, if it's item 1 gets assignment 1, if item 1 gets assignment 1, if item 1 gets item 1 is what we're doing here, it'll skip those statements. Okay. If item 1, if it says item 1 gets item 2, but those items are equal, it'll execute those statements, right? Because if item 1 and item 2 are two different objects that are equal, they'll have different addresses. Right? So that's why I'm using the addresses here instead of comparing the objects themselves. Okay? Yes.
So, if the whole point of using the pointers is to save memory, but every time you make a new object, and for every object that you have in this, you have a separate set of memory allocated, even if it's the same thing. So if it's lawnmower in both places, it's being stored in two places. What are you gaining by doing all of this?
Okay, so the question is, if the whole point of using pointers is to save memory, but you've got a separate copy of lawnmower for each object, what are you gaining by all of this? Did I get that right? So first of all, I'm going to start with the point of all of this is to save memory. Is that right? I'm not sure that's what the point of all of this is. I mean, we've got. I mean, maybe I'm missing something, but you know, all we're doing here is writing an inventory item class. So we could use. So you're suggesting the reason we're doing pointers instead of just using arrays is to save memory. And I would say, well, yeah, we're still, because if we used arrays, how big would we make them? 1,000 characters long? 2,000 characters long? Okay, so if we were just using arrays, we'd be using first of all, we'd probably be using a lot more memory than this. And secondly, we would be limited because we'd have to put some sort of limit on how long our strings could be. And thirdly, even if we were just using arrays, we'd still have to have 2 copies of everything. Right? So if we were using arrays and we had 2 different objects that were both hammer, we'd still have to have 2 different copies of it. So the reason we have 2 separate copies is not because we're using pointers, I guess is what I'm saying. So maybe what's going on is that the reason that this is complicated is because we're using pointers, right? If we were using arrays, we wouldn't have to write an overloaded assignment operator. I mean, if we were using regular old-fashioned array notation. But the reason for that is that C++ would automatically be keeping separate copies of everything. I'll have to go with that for now, I guess. I think I saw another hand. No? Okay. No other questions before we move along here? We haven't tested it yet, right? There we go. After item 1 gets item 1 is 9 hammer. Not as good as the smiley face, that's true. Yeah, I kind of like that smiley face. That's not what I got before when I did it. It's much funner, much more fun. Okay. let's see what I can do next to break this thing. I'm going to introduce a new function above main. So okay, we're about to do like a major, I'm moving on from the assignment operator now. We're done with the assignment operator. So we're going to move on to something else. So I'm going to take this opportunity to do a couple things. Hold on a second. One is, so basically what we're doing today is I am giving you a list of member functions that you have to provide every time you write a class that uses dynamic memory, that has a pointer as a data member. Okay? So every time you write a class that uses dynamic memory, you have to provide a special, you have to overload the assignment operator. Right? Because otherwise, if the client programmer uses the assignment operator, it's going to cause errors in their program. Okay. The other thing I wanted to just throw out is that, I think I've said this before, but I'm putting all of my code in just one file, even though that's really not good practice. And the reason I'm doing it is because it seems to keep things simpler for during lecture, so students can keep track better of what's going on. So hopefully I'm right about that, and it won't confuse you that I'm doing it differently. I saw another hand, I think. No? Okay. I'm seeing hands, yes. All right, so right here, I'm going to have my prototype for this new function. I'm going to say void f in item 1. Okay. And let's see, I think I have a copy of this function down here. So down here I am down below main, and I'm going to put my function definition there. Oops, I don't know why everything's indented. So, so basically what I'm doing here is I'm treating, from here down as if it was a client program, right? So in a client program, it would make sense that you would have a function prototype at the top, and the function definition would be down below main. Okay? So inside that function, what did I do? Whoa. I'm just setting the info on item 1 to 67 pizza, right? Now, in my main function, I'm going to call that new function that I wrote, f, and I'm going to send it item 1. Okay, but I'm using pass by value, right? Inside this function. So after being used as an argument to a pass by value parameter, item 1 is still item 1. Okay, I stuck a couple indels in there to keep it from going on too long on the same line. All right, does it make sense to everyone what I'm doing here? So when I say, so item 1 was, what is it now, 9 hammer? I think it's 9 hammer, right? So when I say F, and then send it 9 hammer, when I'm done, item 1 should still be 9 hammer, right?
Because he didn't add passing it by a reference.
Right, because I'm not passing it by reference, I'm passing it by value. Okay? So if you took your intro programming class and you never quite got pass by reference and pass by value, this could be rough. Okay? But basically the deal is, this is a perfect explanation of what pass by value means, right? When I'm passing by value, whatever the function does, it can't possibly change the thing that I passed. That's the idea, because I'm sending a copy of it. So let's test that out.
I think you have some unwanted semicolons.
Probably. Oh, thank you. Just one. Oh, no, you're right. That better? That would explain the red squigglies. I still haven't gotten myself to like always notice the red squigglies, but I need to keep an eye out for those, huh? All right. So try it. Any guesses? After being used as an argument to a pass by value parameter, item 1 is still 9 pizza. That's not what we were hoping for, right? Any guesses what happened? Well, when I do pass by value, that makes a copy of this. Okay, so when I made my copy, here's what C++ does when it makes a copy. Here's my copy of, can I get rid of item 2? Hold on, let me I'll just squeeze it in here. So here's my copy of item 1. Okay, and so when I'm making my copy, because that's passed by value, I copy the 9 over, and I copy the description data member over, which means that it now points there. Okay, so down here when I say set info pizza 67, I'm okay on the 67 because that goes here. Oops. So now in my mind I have this like hardware store where there's like in one corner there's a little counter where they sell pizza. And when I say change the description to pizza, that changes this to pizza, right? Okay, so let me.
Was hammer orphaned?
No, because I still have this item 1 pointing at. No, hammer was.
Is it deleted in that? By that?
Yeah, it was deleted because inside the set info function we deleted. It got deleted, yeah. So basically it's exactly the same problem we had with the assignment operator, right? And what this comes down to is something that we refer to as a shallow copy versus a deep copy. Okay? What C++ does by default is always just a shallow copy, member by member. What we really want is a deep copy, which means if that member is a pointer to something, go and make a copy of whatever it is that it's pointing at. So that would be a deep copy. So we have to write an assignment operator that does a deep copy instead of the shallow copy. The deal here is that when you do pass by value, what's happening is C++ is calling a function that makes a copy for the called function to use, and that function that it calls is called the copy constructor. Okay, it's just another constructor where the parameter is an object of that type, and so that's how it makes a copy of an object. When C++ does that by default, it just does a shallow copy, which is what you just saw. Okay, so all we have to do is overload the copy constructor so that it does a deep copy instead of a shallow copy, and then pass by value will work. So, copy constructor. It's a constructor, right? So the name is going to be invitem, and the parameter is going to be an inventory item object. Okay. Before I go on, let me just point out that you have to use pass by reference here when you're making your copy constructor. Why do you suppose that is? What would happen if I used pass by value here? So when I use pass by value, what function gets called to make the copy? This function that I'm writing right now. Okay, so if I use pass by value, I'm going to have infinite recursion. I'm going to have the function calling itself over and over again until I run out of stack space. Okay, so has to be passed by reference. So does everyone understand why this would be called a copy constructor? Aside from all this stuff I've been talking about with what doesn't work, okay, I've got a constructor here, just like a lot of other constructors you've seen, but the parameter is an object of the class. So it kind of makes sense that I would call this constructor a copy constructor. It's a constructor that makes a copy of a class object. Okay, let me write it. So no return type.
This has to be one of those required.
Yes. So this is required number function number 2. There's, depending on how you count, there's either 3 or 4 of these. Okay, so let's write our code for the copy constructor. What's the easy part? It's copy me.units. Okay, now I want to say description gets copy me.description, except I know that's not right. So I know that I have to say description gets new, because we've done this several times now, right? New car Sterling copy me.description +1, and then stir copy description copy me.description. Okay. Anybody write down every time that I said here's a rule of thumb today? I hope so, because I want to get a list of those. Here's another rule of thumb, right? Whenever you use stir copy, you just have to stop and make absolutely sure that you have allocated memory, the correct amount of memory for that first argument. Okay. just look like it for the copy constructor, or are we missing something? This is sure a lot simpler than the assignment operator was. Yes.
You still have to delete the description.
Still have to delete the description before I knew it. Okay. I'm glad you said that because actually, this is how the copy constructor this is how a constructor is different from the assignment operator. When we were doing the assignment operator, there was already an object. And so the description was already pointing at something. And so we had to delete it. This is a constructor, which means we're constructing a new object. The description isn't actually pointing at anything right now. So this is my rule of thumb. What is this, fourth or five now? This is actually the cause of a lot of runtime errors that take students hours and hours to track down. So this one you'll want. Never use delete in a constructor. Because there isn't an object already there, so there's nothing to delete. Okay? And so what happens is you'll get a runtime error, but when you go to try to figure out where it's breaking, it won't actually be breaking on the delete statement in the copy constructor. It'll be breaking someplace else. And so it'll take you forever to find it. Okay. Okay, so as it turns out, this is actually it. Okay? We don't need to delete like we did in the assignment operator. We don't need to return anything because the constructor doesn't return anything. And we don't need to check for self-assignment because there's not actually an object because it's already in existence to check that for. Okay? So that's it. Shall I try again? And one's still 9 hammer. Okay? So we got that fixed. I just realized that we've been going for a long time. So, oh, you should have. So why don't we, even though we're only going to have 20 minutes when I get back, that's okay. Let's just take a 10-minute break so the last 20 minutes were like really solid. Okay? Okay, so I've kind of redrawn the picture here, so this is how we ended up. I guess this is sort of a picture of like while we're still executing the F1 function, right? We're right in the middle of executing F1, and I relabeled these so that I've got this is main's copy of item 1 and this is F's copy of item 1. Okay, and so this is how the picture ends up. When we are done executing the function F, this down here just goes away, right? That's what happens when you reach the end of a scope. The local variable on the stack goes away. Now, actually, I'm getting a little ahead of myself, but when we get to the closed curly brace on F1, this over here is on the stack. It's called an automatic variable, so it's going to automatically get deallocated, right? What's going to happen to this over here on the heap? It's orphaned. It's a memory leak. Okay? So we'll talk about that in a sec. There's just a couple more things I want to say about the copy constructor first, okay? There are actually 3 different situations that I know of in C++ where the copy constructor is used. So we talked about one of them, right? Pass by value. Another one is when I return, if I have a function and I return an inventory item object, what I'm returning is a copy of that object. And so the copy constructor gets called in that situation also. Okay? I'm not planning on showing you an example of that, but you know, you could play around with that if you wanted to. Write a value returning function in your client that returns an inventory item object, and then check to see whether that inventory item object that got returned is actually a separate object or not, right? So change it and see if that changed, you know, whatever the original one was, okay? So anyway, I'm not going to talk about that anymore in here. The third time when a copy constructor is called is when you initialize an object. And what's the difference between initializing an object and using the assignment operator? Okay, so it turns out in C++ that when you say this, that is not calling that is not using the assignment operator. The assignment operator is not going to get called there. So right now, if I were to take my copy constructor out and execute this, the same thing would happen as what happened before when we did the pass by value, right? Even though we expect item 3 to be a separate object from item 1, when I change item 3, that's going to change item 1 also. That make sense? So I'm thinking I won't go through the whole process again, drawing the picture and everything. I could just take the copy constructor out and demonstrate that, but hopefully you can take my word for it, right? So, you know, let me just do it. So if I take the copy constructor out, and I execute this now, what's going to happen is item 1, when I see item 1 right here, it's going to have ice cream instead of hammer, right? That make sense? Because when I did this, when I did this, it changed item 1 and item 3 because I hadn't made separate copies of them. Okay? Let's just see what happens. Okay, so actually, the pass by value didn't work either, right? So item 1 is 9 pizza, and then I set item 3 to 9 pizza, and then when I change item 3 to ice cream, that also changes item 1 to ice cream. Okay, so nothing's working right. Okay, so just also to point something else out, in C++, when I say int x gets 7, you probably do that a lot, right? Although it's probably usually 0, but that's actually just an alternate syntax for this. Okay, that's another way of saying it in C++, another way of saying the same thing. And that actually looks a lot more like a constructor being called, right? So really it's the same thing. In fact, I could say, it like that, right? And when I say it like that, it's a little more obvious that I'm calling the copy constructor here, right? Because I'm calling a constructor, I'm declaring an inventory item object, which means a constructor is going to get called. And which constructor is going to get called? Well, the one that takes an inventory item as a parameter. That's the copy constructor. Okay. So I put the copy constructor back in. Try it again. And now everything comes out right. Yeah? Item 1 is still 9 hammer. Any questions? Okay, you guys are getting low energy on me, even with my break. Your break. All right, so I'm done talking about the copy constructor. So now you have 2 functions that you always need to provide every time you write a class that has a pointer as a data member. The next thing I wanted to talk about is this problem we were talking about where we've got a memory leak. Okay, the way I have my program set up right now, when I come back from, whoops, where'd it go? I call F1. When I come back from calling F1, I have this memory down here that is inaccessible, right? Because this got automatically deallocated because it was on the stack, but this stuff out here on the heap doesn't automatically get deallocated. Any ideas about how we're going to make sure this gets deallocated? Close. Destructor. Unconstructed. Yeah, unfortunately, no. So yeah, that brings up an interesting point, actually. Those of you who have some experience with another programming language, Java, for example, will know that there is no delete in Java because all of the deallocation of memory on the heap is done automatically. Why do you suppose they don't do that in C++? Because it's older? No. Because Java's better? No.
They expect you to know exactly what you're doing every minute, every time, with every variable?
They expect you to know exactly what you're doing every minute, every time, with every variable in C++. That's true. I guess the question is why would they expect that? Any no guesses? Okay. Everyone's done guessing? Because it's very inefficient. Right? Java's slow. Java's not a fast language. And one of the reasons is that every once in a while it goes through and it looks at all the memory and makes sure that there isn't anything that needs to be deallocated. Does that make sense? Most of the time, doesn't matter, right? But one of the philosophies behind C++ is we're going to provide a lot of stuff here, but we're never going to take away the ability of the programmer to write code that is as efficient as possible. And in Java, that's not the philosophy, right? Yeah. Anyway, end of digression. Okay, I forgot what I was doing. Oh yeah, destructor. Okay, so basically what we need to have is we need to see, imagine you're creating C++ and you're dealing with all this memory stuff, and all of a sudden you realize that, oh, there's no way in C++, given what I have told you so far, to handle this situation. And what am I going to do? Well, I guess what I need to do is I need to provide a way that the programmer programming the class can provide a function that automatically gets called at the end of a function. So in other words, whenever an automatic variable goes out of scope and gets deallocated, this function that I'm talking about is going to automatically get called. And the reason for that is so that I can deallocate whatever memory that automatic variable was pointing at. Okay, so it's called a destructor. And the way a destructor works, it's actually pretty simple in C++. Destructor is not going to be a big deal. You just have to remember to do it. So it's the same as a constructor. So no return type, same name as the class, except I just precede it with this little tilde. So tilde in item, no parameters, never going to be a parameter in a destructor. Okay. So when I implement the destructor, hold on a second. Okay, so what do I want to do in the constructor? Did I say constructor? Destructor. Deallocate the memory, yeah. Delete description. Okay, so this gets called right before the end of the function f, which means this gets deleted, and then we're good. No more memory leak. Okay?
You have to explicitly call it in your function at the end, or does it?
No. It automatically, it's just like the constructor. It automatically gets called. So, yeah, I wouldn't have to have any sort of special notation if I had to call it explicitly. But if I had to call it explicitly, that would be asking an awful lot of the client programmer, right? The client programmer would have to know that, you know, this is dynamic memory being used, so every time I declare an automatic variable of this type, at the bottom of the function I have to explicitly call this function, whatever, right? So C++ makes it so that it gets called automatically when that object goes out of scope, or is being deallocated on the stack. Yes?
If you have a pointer to an item object and you call delete on that, will the destructor you call there too?
You call delete on a pointer to an inventory item object. My brain can't quite get around that. I know it makes total sense, but let me, let's see, I've got a pointer, and then I delete it. For some reason, my brain won't quite go there. So hold on to that and make sure I answer it. Like, I'll figure it out before next class and answer it in the next class, okay? All right, so am I done talking about the destructor? That was pretty easy. Okay, so that's 3 functions that you have to provide for every time you have a class that has a pointer data member. That third one is a little bit tricky because if you don't provide it, no one will ever know, right? Unless, you know, the client programmer who's using your class decides to have some sort of situation where it's allocating and deallocating these things a lot. He or she will run out of memory. Okay? Yeah.
So this what's it called?
Destructor?
Yeah, the destructor functions call it no matter what, so it doesn't need to be placed in any particular place.
Correct.
Okay.
Yeah.
Just wanted to make sure everything was good stuff.
Yep. No, it doesn't have to be placed in any place in particular. You just throw it in there and it's taken care of for you. Okay? The one other thing I would say is, so usually when I say that, tell you how many functions there are that you have to have, I include a fourth one, which is you have to have a default constructor. Okay. A lot of times, and maybe in your textbook, I can't remember, they'll say there's 3, and they won't include the default constructor because, well, the default constructor, the only reason you have to have a default constructor is because if you have any constructor, you have to have a default constructor. Does that make sense? So because one of my 3 is the copy constructor, that means you're going to have a default constructor. Usually you can just not even remember that because you're going to have a default constructor anyway, right? But I'm throwing that in there just to be complete. Well, and so, hold on just a sec. Okay, so yeah, I'm pretty sure that you'll get a syntax error if you try to create a class that has a constructor but doesn't have a default constructor. Okay, I can't promise that, but I'm pretty sure I'm right about that. But in any case, if you don't have a default constructor here, just imagine that you could do that. What's going to happen if you declare an object of type inventory item and then it goes out of scope? So you would declare the object of type inventory item, you'd have an uninitialized pointer, and then you would, in the destructor, you would try to delete it, and you'd get a runtime error. Your program would crash. Okay? So that's why you have to have a default constructor. Any questions about any of that? Okay, so that was the main thing that I wanted to get through today. There's just 2 more things that I need to talk about in order to be completely done and for you to be completely ready for assignment 2. And that is, we're going to be overloading the square brackets, and we're going to be overloading the extraction operator, which I'm not sure if there's anything new in there or not, but I guess I would say you might just want to hold off on those parts of the assignment until after Wednesday's lecture. But yeah, you can get started on assignment 2, and you can do everything as long as you stay away from the square brackets and the extraction operator. And let me just encourage you to, if you've got a bunch of classes and you're trying to figure out how to prioritize them, now would be a good time of the semester to prioritize this class, and then you can prioritize your other classes probably a little bit later. Okay? All right. Yeah.